Alright, in this video we're going to go over complex numbers part 1. Early cue for this lesson is how do you graph and perform mathematical operations with complex numbers. Alright, here's your vocab for this unit. Imaginary unit, I, is the complex number whose square is -1. So anytime you see a cursive I from now on, it is going to represent the imaginary unit, which is the square root of -1. Alright, imaginary number. Any number of the form a plus bi, where a and b are real numbers and b does not equal 0. Now, a complex number. A number written in the form of a plus bi, where a and b are real numbers. Now, I know complex number and imaginary number sounds like the same definition, and they are very similar. Alright? They are very similar. In fact, you'll hear me call them complex numbers the majority of the time when they're in the form of a plus bi. Alright, now a pure imaginary number is a number in the form of a plus bi where a equals 0 and b does not equal 0, and the resulting form is just bi. So it's just the imaginary part of the complex number. That is a pure imaginary number. We'll go over that a little bit more later. Now, the absolute value of a complex number, so the absolute value of a plus bi equals the square root of a squared plus b squared. All right, so you take a and square it, you take b and square it, and you have the absolute value of a complex number. All right. All right, so moving on. Simplify a number using I, or the imaginary unit I. Alright, so how do you write the square root of -18 by using the imaginary unit? Well, it's actually fairly simple. We know that the square root of -18 equals the square root of -1 times 18. Alright, and we know this can be broken apart into the square root of -1 times the square root of 18. Alright, and we know, of course, that the square root of -1 is now I. Alright, and we know that the 18 can be broken down into 9 times the square root of 2, or 9 times 2, which is I times the square root of 9 times the square root of 2. The square root of 9 is 3. So therefore, this can be written as 3i times the square root of 2. Alright, so basically what you can see here is we pulled out the square root of -1 and got I. Then we simplified the square root of 18 down to 3 times the square root of 2, and we added the I after the 3. Alright, so when we're doing this section, you're gonna need to be able to take square roots like the square root of 18 and write it in simplest radical form. To do that, you just take the square root of 18. Well, that breaks down into 9 times 2, and then 9 breaks down into 3 times 3. This is another way to do it. If you don't want to do it this way, this is another way to do it. Alright, since we have a pair of 3's here, we can pull a 3 out from underneath the square root, and now we're left with a single 2, so he has to stay underneath. Alright, so again, here's 3 times the square root of 2 again, which is the same thing we got here. Alright, but if you're good at recognizing perfect squares, it'll probably be faster to do it this way, because if you recognize the perfect squares, you know that 18 is simply 9 times 2, 9 being the perfect square. You can separate the square roots into the square root of 9 times the square root of 2. Then, of course, the square root of 9 is 3. Bring down the I, square root of 2. Alright, so that's how you simplify a number using I. So here's a few for you to try. How do you rate each number in parts A through C by using the imaginary unit I? You have the square root of -12, you have the square root of -25, and you have the square root of -7. Now, letter D says, explain why the square root of -64 is not equal to negative the square root of 64. So pause the video and figure these out. All right, let's look at A. A is the square root of negative 12. Well, we know the first thing we can do is separate this into the square root of negative 1 times the square root of 12. And then the square root of negative 1 becomes I. Now this here, the 12 becomes the square root of 4 times the square root of 3, because 3 times 4 is 12. And of course, the square root of 4 is 2. So 2, bring down your I, and then square root of 3. So letter A reduces down to 2I times the square root of 3. All right. Now let's go to B. We know immediately it can be broken down to the square root of negative 1 times the square root of 25. We know that the square root of negative 1 is I. We know that the square root of 25 is 5. So I times 5. But remember, always put the I after the constant. So the correct answer here would be 5I. All right. So remember, break it up. Square root of negative 1 times the square root of 25. Square root of negative 1 becomes I. The square root of 25 becomes 5. So the answer is 5I. All right, and C. Remember, the first thing you can do is go ahead and break it into the square root of negative 1 and the square root of 7. Square root of negative 1 is I. Square root of 7 is simply the square root of 7. So the answer here is I times the square root of 7. All right. Anytime you have a square root, put your imaginary number in front of it. But if you don't have a square root, like in this case, we just have a constant, put your I behind the 5. Or in this case, put it behind the 2 in front of the square root. All right, so 3 different cases. Make sure you're putting your I in the correct spot. All right, now letter D. Why doesn't the square root of negative 64 equal negative the square root of 64? Well, if we break down the square root of negative 64, that's going to give us square root of negative 1 times the square root of 64. Square root of 64 is 8. Square root of negative 1 is I. And if not equal to negative square root of 64. And if we break this down, well, the square root of 64 is 8. So this is essentially just going to equal negative 8. Well, 8I does not equal negative 8. So that is why the square root of negative 64 does not equal negative square root of 64. Because remember, when you have a negative underneath the square root, you're going to have the imaginary unit I in your answer. All right, you're going to have the imaginary unit I in your answer. All right, now graphing in the complex number plane. Now, the complex number plane and the coordinate plane look very similar. As you can see here, you can't really tell which plane that is unless I tell you. This is going to be the imaginary plane. Now, the y-axis, in quotes, is now your imaginary axis. All right? Your y-axis is your imaginary axis. And the x-axis is your real axis. All right, so how do we graph a complex number? Well, look at this is x and this is y. So we're going to go negative 5, so 1, 2, 3, 4, 5 on the real axis. I'm just putting a dot there for reference, that's not the actual point. And then plus 3i, so we're going to go up 3, 1, 2, 3 on the imaginary axis. All right, so we went over 5, because that's minus, so we went back 5. And then we went up 3, because we have to go up 3 units on our imaginary axis. So this is the point, negative 5 plus 3i. That is the point, negative 5 plus 3i. Now, let's graph B. And then we're going to find the absolute value of these two numbers. Now here, we don't have a real part, which means we're just going to go up 6. 1, 2, 3, 4, 5, 6. We're just going to go up 6 on the imaginary axis. So this is the point 6i. Alright, so we're just going to go up. Now, let's find the absolute value of each of these numbers. If you remember, the absolute value of a plus bi is simply the square root of a squared plus b squared. So, the absolute value of negative 5 plus 3i is the square root of negative 5 squared plus 3 squared. Notice I didn't bring the I with it because b is just the number in front of I. It doesn't include the I itself. So this is going to be the square root of 25 plus 9, which is the square root of 34, which doesn't break down. Nope, it doesn't break down because it goes to 2 square root of 17. 17 is a prime number. So the absolute value of negative 5 plus 3i is simply the square root of 34. Alright, you just do a squared plus b squared. This is a, and this is b. Don't forget to bring the signs with them. Well, I guess it doesn't matter because you're squaring them. So 25 plus 9 is 34. So the absolute value of negative 5 plus 3i is 34. Alright, now let's do b here. I'm going to change colors. I'm going to do this one in blue. Alright, so again, this is our equation. So the absolute value of 6i is simply going to equal, since we have no imaginary part, since we have no real part, that is 0. And this is a pure imaginary number because it's just 6i. So if we go back to your vocab, a pure imaginary number, it only has an imaginary part. So 6i is a pure imaginary number. So this is in a sense going to be 0 squared plus 6 squared, which equals the square root of 36, which equals 6. So as you can see, when you have a pure imaginary number, so you just have a number in the form of bi, all right, when you have a pure imaginary number, the absolute value of that is simply going to be the value of b. All right, so the absolute value of 6i is just 6. You really don't need to do the math for that because you're going to square that. You're going to square the 6 and then immediately turn around and take the square root of 6. So the absolute value of 6i is just plain old 6. All right, it's just plain old 6. All right, so what are the graph and absolute value of each number? So go ahead and graph these real quick and find the absolute value of each one of them. All right. So 5 minus I. So we're going to go over 5 on the real axis. Because this is your real axis. And this is your imaginary axis. All right, so we're going to go over 5. 1, 2, 3, 4, 5, and down 1. So that's the point 5 minus I. Negative 3 minus 2i. 1, 2, 3, 1, 2. So that's the negative 3 minus 2i. And then 1 plus 4i over 1 up 4. 1, 2, 3, 4. So that is the point of 1 plus 4i. So let's find the absolute value. So absolute value of 5 minus I is simply the square root of 5 squared plus negative 1 squared, because remember there's an imaginary 1 there. So this is going to equal 25 plus 1, which is the square root of 26. So the absolute value of 5 minus I is the square root of 26. All right. Next, let's do this one. Absolute value of negative 3 minus 2i is going to equal the square root of negative 3 squared plus negative 2 squared. This is going to equal 9 plus 4, which equals the square root of 13, and 13 is a prime number. So that is written in simplest radical form. So B, the answer is the square root of 13. All right. Now let's do the last one. Let's do letter C. This was A, this was B, and now let's do C down here. All right, so we're going to do the absolute value of 1 plus 4i. That's going to equal the square root of 1 squared plus 4 squared. So that's going to equal the square root of 1 plus 16, which is the square root of 17. So the absolute value of 1 plus 4I is the square root of 17. Alright, so that's all there is for graphing these things and figuring out the absolute value. Alright, last thing we're going to go over in this video is adding or subtracting complex numbers. Alright, now when you add or subtract complex numbers, it's actually fairly simple. If you imagine the I as an X, alright, you can add a constant term, like you can't add 5 to 5x and get 10x. You just can't do that because the 5 doesn't have an x. Alright, let me write down what I'm saying. So you can't go 5 plus, I'm going to change this to 6x, and say this is 11x. Alright, because this 5 has no x value. So 5 plus 6x just has to stay 5 plus 6x. But if I also said, say, plus 3x, now we could combine these two because they both have an x and get 5 plus 9x. Right? That's the same thing with imaginary numbers. You add the real parts and then you add the imaginary parts and you keep them separate. You can't add them together just like you can't add these together. 5 plus 9x, you can't add that together and get 14x. Alright, so i's work the same way. So we're going to do 4 plus negative 4. And then we're going to add that to negative 3i plus 3i. So 4 plus negative 4 is 0, plus negative 3i plus 3i, well, negative positive, that's also 0. So the answer to A is simply 0. All right, you add the reals, you add the imaginaries. You can't add them together. Okay, let's go to this one. Now this one's subtraction here. All right, this one's subtraction. Since this one is subtraction, it still works the same way, except now we're going to subtract them instead of add them. All right, so we're going to have 5 minus negative 2, which is plus 2, and we're going to have minus 3i, and then we're going to subtract 4i, and then we're going to subtract 4i from it. So 5 plus 2 is 7. Negative 3i minus 4i is negative 7i. All right. Now, we have to leave it like that. We can't subtract 7 from 7i and say it's 0. We can't do that. We have to leave them separated. All right. Just like if these had x's behind them, you can't add, like if these were x's, you couldn't add this 5 or 2 to the 3 and to the 3 or the 4. You just can't do it. All right. So you add the imaginary parts, you add the real parts, and you have to leave it at that. So try these. What is the sum or difference? All right, so add these 4 or subtract these 4 real quick. All right, A, we're going to have 7 plus negative 3, or 7 minus 3, plus, and then we're going to have negative 2i. I don't know why I wrote that plus. I really don't. Then we're going to have minus 2i plus I. So we're going to have 4 minus I. All right, we're going to have 4 minus I. All right, let's move on to the next one. Letter B. Now, what I would do is go ahead and distribute this negative 3. So you have 1 plus 5i minus 3 plus 2i. All right. Now that we distributed negative 3, we can just combine these things. 1 minus 3 is negative 2. And then 5i plus 2i is simply plus 7i. All right. Let's look at letter C. Again, just distribute that negative through there. So you have 8 plus 6i minus 8 plus 6i, which is 6i. All right. So the 8's cancel. 6 plus 6 is 12i. All right. So C, you should have got 12i. And lastly, letter D, we're going to have negative 3 plus 3, which is 0, and then plus 9i plus 9i is 18i, so this is simply 18i. All right. So that is it for Complex numbers part 1. Feel free to watch this video as many times as you need to. And make sure you come tomorrow ready to work some problems. See you tomorrow.